Dr. Ranjani Parthasarathy is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. This is a series of lectures in computer architecture. With respect to computer architecture, we have been looking at the basic building blocks. So, we looked at the main control unit, that is what we looked at in the previous lectures. So, with respect to control unit, we looked at how a simple control unit can be designed, and we also looked at how pipelining is done, and we also looked at some advanced concepts. Now, it is time to look at other units that we have in the processor. So, we know that we have the control unit, the input unit, the output unit and the memory unit. So, it is the memory unit that we are going to take a look at today. So, specifically today what we will do is we will take a look at some of the fundamental concepts that we have in terms of how a memory is accessed, and we will also take a look at some memory devices. So, let us look at some basic concepts first. So, if you look at what we have, a processor typically will be interfaced to some memory device. Now, what are the lines which constitute the interface? If we look at that, you will have the address bus which will come from the processor to the memory. You will have the data bus which is connecting up the two. So, you will have data flowing from the processor to the memory as well as from the memory to the processor. So, this is a bidirectional communication that will take place on the data bus. The address bus will be unidirectional because you will have address being sent from the processor to the memory. And then we will have control lines, a read write control line, and maybe you may also have a control which comes back as a feedback from the memory when an operation is completed. So, this is typically what you will have in terms of the interface between a processor and a memory. So, when we talk of any memory device, therefore, we need to understand how the addresses will be specified, how the data at that particular address will be obtained, and what will be the control lines that need to be specified for that. When we talk of memory again, there are certain terms that we normally refer to. We refer to the maximum size of the memory. And here I am talking about main memory because we are talking about the physical memory that is available for a given machine. So, now if I say that there are 2 power k addressable locations, okay, then I would say that I have a 2 power k big memory. Okay. So, when I say that addressable locations, if each location stores n bits of data, or let us say stores 1 byte of data, then we say that it is byte addressable. That is, if every byte is given a unique address, then we say that the machine is a byte addressable machine. Most of the processors today, when we talk about memory, we normally refer to it in terms of byte addresses. The actual length of a word could be even greater than a byte. So, in which case, let us say for instance a word had 32 bits, that is, it will actually have 4 bytes that can be in it. So, the memory may be organized as words which have actually 32 bits or 4 bytes. Okay. But when you have 4 bytes in it, and if you say that the memory system is byte addressable, then it would correspond to 4 different bytes. So, there will be 4 different addresses which will uniquely identify the 4 bytes which are there in that particular word. But the whole word itself will be identified either by means of the referring to the least significant byte in that word or the most significant byte in that word. So, these are the 2 options that we would normally have. We talk about byte addressable memory systems. Okay. So, now let us take a look at some measures that we talk about when we talk of a memory system. One of the terms that we use is a memory access time and memory cycle time. See, these are 2 terms that we normally use. So, when we talk of memory access time, what we are talking about is from the time that the address is specified, how much time does it take for the data to be retrieved from the memory. So, we talk about that as the memory access time. So, we talk of memory cycle time, we talk about how much time it takes for a full operation to be completed, and after how much of time can I start the next operation. So, for instance, let us say I am accessing 4 words from memory. So, I have accessed 1 word, then I want to access the second word, third word and the fourth word. So, a memory cycle essentially will talk about specifying the address for one particular word, accessing that, and then when can I specify the address for the next word that needs to be accessed. So, we talk about memory cycle time. So, access time and cycle time are both important. In fact, when we are reading from memory, access time is specified with respect to time taken from the time that the address is placed and the data becomes available. So, when you are doing a write operation, we need to take other things into account because the address will be specified and the data will be specified. So, you will specify the data and you will give a write control signal to memory, but your data will have to be present at the interface for quite some time before the data actually gets written into the memory. So, we normally refer to that as setup time, and you have to hold it in that place for some time. So, we call that as hold time. So, setup time and hold time are also two other terms which are used when we are talking about memory with respect to write operation. But normally when you say cycle time, it is with respect to both read and write operations. So, for our understanding, we can just worry about cycle time, need not worry about the other things for our general understanding. Another important design issue is to provide a computer system with as large and fast memory as possible within a given cost target. Okay. So, now what we need to therefore understand is, okay, I have got a memory, I have got some amount of memory that can be stored, I give you one device, that device has some capacity. So, what will be the cost of this particular device and how fast can I access data from this? So, again you can see our access time and cycle time are important factors. How large is my memory system and how fast can I access it, and what is the cost? This is a very important aspect. Okay. So, you will find that within the memory system there is normally a huge hierarchy of different devices that we use. We talk about modules which hold large amount of data, but which are normally very cheap devices, but they may not be very fast. And as we go to faster and faster memory devices, you will find that they will also become smaller in size, and that is the amount of data that they hold may be smaller, but the cost that is involved will be higher. So, if you look at a memory system as a whole, we will find that we use a mix of devices. We use devices which are fast, we use devices which are slow. So, fast devices are costlier, slow devices are cheaper, and we use a combination of these two to match the cost and the capacity that we need. So, it is a capacity cost trade off that we have, and that we manage by using a combination of these kind of devices. Okay. So, you will find that some of these terms we will look at later, but just to mark these terms in your memory. So, there are several techniques that we use to increase the effective size and the speed of the memory. So, one is called cache memory, you must have heard of this term. This is something which is used to increase the effective speed of the memory. So, similarly we used another concept called virtual memory, which is to increase the effective size of the memory that you have. So, I told you speed, size are both important, and similarly cost. So, there are actually three factors that we need to look at: speed, size and cost. So, there are various techniques that we use for this. We will first take a look at the different devices that are available, and then we will look at how the cache memory is constructed and how the cache memory is integrated in the memory system, how the virtual memory is used, how that is integrated in the memory system, and so on. Okay. So, this is what we will look at broadly with respect to a memory subsystem. So, let us look at first semiconductor RAM memories. So, this is something that you would have definitely heard of. We talk about RAM chips. Okay. So, we have let us look at what any particular chip, a memory chip looks like from the inside. What is the internal organization of a memory chip? So, let us take a look at that first. You can see that there are number of cells that we have here. Okay. So, your memory essentially is organized as an array of cells. Now, each cell will store one bit of information. So, that is the way it is normally organized. We have you can see that there is a single line here to which many cells are connected. Okay. If you look at it horizontally, there are lines here. Horizontally, these cells are connected to these lines. So, these are referred to as word lines. So, we talk about a word line. So, there are bits of a word are connected to this word line. So, once you select a word, all the bits in that word would typically be selected. Okay. That is how it will be organized. And then you will see that there are two lines which are shown to the left and right of each cell. So, these lines basically are used to read and write data into these cells. We have what are called as sense or write circuits which are used. Okay. And you can see that the data lines are connected to these sense and write circuits. We have these memory cells, data stored within these memory cells, and then these memory cells are essentially flip flops. You can just look at them as flip flops which are used to store one bit of information. Of course, we will look at how exactly the structure of the cell is shortly, but just for your understanding now, you can look at it as one bit of storage. Okay. So, you have a word line which connects all these cells which belong to a particular word, and then there are read write lines which are connected to each of the cells. Okay. And you can see that there will be a sensing or a read write circuitry. Now, the sensing circuitry is used when you are reading data. Write circuitry is when you are writing data. So, both the read and write are controlled by this sense/write circuit here. So, you can see that the data lines are connected to these particular sense write circuits. So, the control for this, the read write line, okay, and what is called as a chip select, saying that this particular device is being selected, are normally given to these circuits that you have here. Okay. Now, one more thing that we need to look at here, you can see that there is one more block here called the address decoder. Okay. So, what this will do is, given an address line, okay, it will decode what is the address and select the appropriate word. So, you can see how the whole thing will work. So, let us say we had a 4-bit address. So, you have 4 address lines. So, the address decoder essentially is a 4 to 16 decoder. So, it will select one of the 16 words that you have. So, you have words going from W0 to W15 over here. So, this W0 to W15, one of these words will be selected, okay, one of these word lines will be selected depending on the address. And at each address, we can see that we have 0 to 7, 8 bits which are being stored. So, these 8 bits will be now read out through these sense write circuitries from the particular word line that has been selected. So, note that even though all the cells, okay, they can see that their left right portion is connected to a single line, only that particular cell which is selected by the word line will be the one that is sending its input or output to the sense write circuitry. Okay. So, when you are doing a read operation, you will specify the address here and you will specify a read operation here, and whichever word line is selected, all the corresponding bits over there, that information alone will be read out in this by the sense circuitry here. Similarly, when you do a write operation, the data to be written will be specified in the by the write circuitry to this through these side lines, and whichever word has been selected, whichever address has been selected, into that particular word the data will be written. So, this is how the read write will take place in any typical memory structure. So, normally whether it is static RAM or whether it is dynamic RAM, these are terms that we will discuss in detail later. Whatever be the type of RAM, you will normally find that it is like this. It is basically an array of cells, and you will have addresses specified and the data that is sent to it through the sense and read write circuitry. So, this is what you will have. So, to just recap whatever I said just now, as I said, each memory cell will have 1 bit of information and the memory cells are organized in the form of an array. So, one row is one memory word. Okay. So, all cells of a row are connected to a common line which we call as the word line. So, the word line we said is connected to the address decoder, and the sense or write circuits are connected to the data input output lines of the memory chip. So, now we will take a look at what an SRAM cell looks like, that is we are talking now about a static RAM cells. Now, when we talk of RAM, we talk about 2 types of random access memory cells. We talk about static RAM and we talk about dynamic RAM. So, we will now take a look at what a static RAM cell normally looks like. Okay. The way a static RAM cell is constructed is using a very simple circuitry which consists of 2 inverters. So, we will just take a look at that picture. So, there are 2 inverters connected back to back, okay, and you have 2 transistors on either side, okay, and these transistors are the gate of the transistors is connected to the word line, as you can see over here, okay, and the 2 sides that we saw, okay, you have a line B here and a line B dash which are connected to the 2 ends of the transistors, the 2 ends of the 2 transistors, okay. So, now this B and B dash are the bit lines, and these are the lines that will actually go to your sense circuitry or the write circuitry. So, the word line, we already seen what the word line is. So, the internal cell, if you look at, is as simple as this. It just has 2 transistors connected back to back with 2 transistors for sensing the state of the particular cell. There are just 2 inverters which are cross connected to form what actually is a basic flip flop. Okay. So, with this kind of a structure, we are able to store a bit, 1 bit of information, either a 0 or a 1. So, we will just take a short break and come back and look at the details of this. Welcome back after the break. So, we were just taking a look at the structure of a static RAM cell. So, as we said, it is 2 inverters connected back to back to store a bit of information, either a 1 or a 0. So, let us look at how a 1 or a 0 is stored there. So, as you can see, the cell that we have is connected to a word line and to 2 bit lines by the 2 transistors T1 and T2, and the word line is at ground level. Okay. The transistors are turned off and the latch retains its state. So, that is what we will see over here. So, you can see that the word line is connected to the gate of the transistors when it is at ground level. So, these two transistors are turned off, and so whatever data is here, that is stored inside this flip flop, okay, or the simple circuit which can store that information. For a read operation, what is it that needs to be done? In order to read the state of the SRAM cell, the word line is activated to close the switches T1 and T2, and the sense write circuits at the bottom monitor the state of B and B dash. So, you can see what happens. So, when the word line is high, so these two transistors are switched on. So, the value here, whatever value here will be B, that will be sensed on the B line, and so B dash will be sensed over here, and so B and B dash will be the value that is taken care of by the sense write circuits, and from there you will determine whether there is a 1 that was stored here or whether it was a 0 that was stored here. Okay. So, you can see it is basically just a simple flip flop kind of a circuit that is inside with a pair of transistors which is used to sense the output of this flip flop. That is all that we have as the basic SRAM cell. Now, these static RAM cells, if we look at how from the way they operate, we can see that there are certain characteristics that they have. The characteristics basically are that these are what are called as volatile memories. So, what we mean by volatile memory? These circuits, they can retain their state as long as the power is applied. Okay. So, once you switch off power or power is interrupted, the contents will be lost. Okay. So, we refer to these as volatile memory devices. So, when power is on, whatever data you have stored there, that data will be there as long as power is there. The moment you switch off power, you will lose the data. So, we refer to these as volatile memories. Now, these volatile memories, you can see that the structure of the cell that we looked at was it's a very simple structure. So, because of the simple structure, you will also find that the access times are very low. So, it has a range of a few nanoseconds. Remember, nanoseconds is 10 to the power of minus 9. Okay. But the cost usually is very high. So, that is the characteristic of a static RAM. Very fast access, but the cost is high. Okay. So, that is what we have with respect to static RAMs. Another type of RAM that we use is what is called as a dynamic RAM. Okay. So, you can see the moment we talk about a static something, then dynamic will be something which is slightly different from that. So, let us look at what a dynamic RAM will be. The dynamic RAMs, the basic difference is that they will not retain their state indefinitely. That is, we said that for a static RAM, it is a volatile memory, and once you switch off power, it will lose the data. But if you do not switch off power in a static RAM, whatever data you have written, that data will be maintained in that flip flop. Okay, it will be held in that flip flop forever as long as power is maintained. Okay. Now, with a dynamic RAM, you cannot even do that. That is, if you store some data, after some time the data is likely to be lost even though the power is applied. So, which means we will have to keep on refreshing that content periodically. Okay. Because it does not retain the state indefinitely, what we need to do is we have to periodically refresh the contents which are stored. Okay. So, how do we do this thing called refreshing? What do you mean by refreshing? What we are saying here is, after some time it is likely to be lost. Because it is likely to be lost, I will have to store that value back again. I will have to write it back and make sure that the data is maintained at the same value. How do I do this refreshing? Normally the contents may be refreshed in dynamic RAMs by accessing them for reading. If you just access it once, you will find that it is again refreshed. The dynamic RAMs again, what is it that makes it lose its data periodically? So, if you look at that, you will find that the dynamic RAM structure, in each cell, what we have is actually just a simple capacitor. So, you will have a capacitor and one transistor to sense the state of the capacitor. So, when you say I am storing a value of 1, it is just charging the capacitor. So, as long as the capacitor holds that value, holds that charge, you will find that it is holding that value which is stored over there. But unfortunately, we know that with capacitors, they will discharge over a period of time. So, that is the reason why these dynamic RAMs lose the charge that we talk about. Okay. So, which is why we need to again periodically refresh them by just reading the device. So, this refresh is an important aspect of dynamic RAMs. Okay. So, we will look at how the full structure of any dynamic RAM will be there, including the refreshing that needs to be done. So, if you look at synchronous DRAMs, how they are organized, again they are organized as cell arrays. So, you will have rows and columns again as to represent the array, and the density of the dynamic RAM will always be higher than the density of a static RAM. That is because each cell consists of just a simple capacitor and a transistor associated with it. The space occupied by each cell is smaller, and you will actually be able to pack more number of cells in a given area. So, which is why dynamic RAMs normally within the same cell area you will find a dynamic RAM is storing much more data than a static RAM, and it also makes the dynamic RAMs cheaper than the static RAMs. So, given that, we are always looking at packing more and more data into the dynamic RAM cells. Okay. So, now that you have this, now that we have decided that a lot of data is to be stored, how exactly is the data stored? So, if you want to understand that, we can look at from this particular picture here. So, we have an array of cells, okay, that is what we have, and normally we have different planes of this kind of a cell array. So, if I have for instance, let's take this particular example that we have here. Let's say each row can store about 512 bytes of data. Okay. So, now what we will do is we will first select a row and then we will select a column within that row. Okay. So, what we do therefore is each row which can store 512 bytes. So, we use 12 bits to select a row and we will use 9 bits to select a group in a row. So, total of 21 bits is used to select a particular piece of data here. Okay. So, let us look at what we do there. So, what we will do therefore is the way we use this is that we will first select a row. So, the addresses themselves will come in two parts, that is we will first send the row address and then we will use the same address lines to send the column address. Okay. So, you can see that we are actually multiplexing the address lines that we have, the total number of address lines, because if you have a very large memory structure, the number of address lines that we require will be very large. So, when you have many address lines that need to be given to a particular chip, you will find that occupies some space. So, to optimize on that, what we do is we divide the entire addressing into row addresses and column addresses and use the same lines to first send the row address and then send the column address. So, which is why you will find that we have something called a row address latch over here and a column address latch over here. So, I will first send the row address, and when I send the row address, I send a signal called the RAS signal or the row address select signal. Okay. So, you first apply the row address and send this RAS signal along with this. Okay. So, this is an indication that what is coming in is a row address, and so this RAS signal will be the one that enables this row address latch. So, when the row address latch is enabled, whatever address is coming here, that will be stored in this row address latch. So, we have got the row address in this latch, and so this address now will go to the decoder. This decoder will select one of the rows that we want. Okay. So, that is what we have. Now, after we have given the row address and the row decoder has decoded it, it has selected one particular row. Now, the column address signal will be given. So, when the column address signal is given, at the column addresses, these lines, the signals which are coming on the address now are the column address lines. Okay. So, this address is given here, and at the same time this CAS signal, which is the column address strobe signal or the column address select signal. Okay. Normally it is a strobe that is used over here, so you call it as the column address strobe. So, this column address strobe is the one that will now enable this column address latch. So, because this is selected, whatever address lines are coming here, that will be latched into as the column address. Now, this you can see goes to the column decoder. So, the column decoder now will decode and select the correct column, and we will get the data here as your data lines. Okay. So, D0 to D7, if there are 8 planes here, from each plane you may get one data line that is being selected. Okay. So, this is how the whole thing will work, and of course, you have your sense and write circuits in between as usual. Okay, which will be controlled by the read write lines. This is the same as what you will have in I mean, it is similar, not same exactly, it will be similar to what we have in the static RAM circuit. So, this is the overall structure of our dynamic RAM. So, what is important here when in this structure is the RAS and CAS signals and how they are generated. Okay. So, the timing of the memory unit is controlled by a specialized unit which will generate the RAS and the CAS, because we need to first give the RAS, latch it and then give the CAS. So, the timing here is important. So, normally we have special controllers for DRAM which will take care of generating this kind of a RAS and CAS circuitry. This is the basic DRAM circuitry that we have, but there are also certain other faster modes of access that are provided on the DRAM circuitry. So, we have something called a fast page mode that is normally supported on most of the DRAM devices. Okay. So, what we have in a fast page mode is essentially this. Let us say we want to access the consecutive bytes in the selected row. Okay. So, this can be done without having to reselect the row, as we saw here. So, we know that we first have to select a row and then select the column, and then whatever the data is there in that particular column, that is being accessed, right. So, this is what we said. So, what I am talking about now is, suppose we say that I want to access the successive columns in this row. So, now which means I do not have to apply this row address again, because I have already selected the row. Can I be allowed to just change the column address alone and then be able to access all the data that is there in that particular row. So, if you are able to do this, this is called as a fast page mode. This can be done without having to reselect the row. So, what we do is we add an additional latch. Add a latch at the output of the sense circuits in each row, and all the latches are loaded when the row is selected. So, different column addresses can be applied, and then you will be able to select and place the different bytes on the data lines. Okay. So, these are certain enhancements that are done to the basic dynamic RAM circuitry in order to get the faster access also with these dynamic RAMs devices. Consecutive sequence of column addresses can be applied by controlling the signal CAS that we have here. Okay. So, remember, CAS is our column address strobe. So, row address strobe we do not change, that has already been given. Now, you keep changing the column address strobe, okay, and this will allow different bytes of data which are in consecutive columns to be transferred to your buffer, and then from there it will be transferred to out of the device. To summarize, what we have looked at in today's lecture is the following. So, we have looked at the basic concepts of a memory system. So, we looked at the interface that we have for a memory system, address lines, data lines, and the control lines required, and we briefly talked about the performance measure, which is the memory access time and the cycle time, and then we looked at some devices. So, we looked at random access memory devices, we looked at the structure and addressing of two different types of RAM devices. One was called as a static RAM and the other is a dynamic RAM. Now, RAM device essentially is a volatile memory, but we looked at, in being volatile itself, how the static RAM and the dynamic RAM are different from each other. And when we talked about dynamic RAM, we talked about why it needs to be refreshed, and we also looked at a particular mode of operation called the fast page mode of operation in dynamic RAM. Okay. Questions to review the content that we have looked at today. Question number 1, what are the signals required to interface to a memory device? Question number 2, with 10 address lines for a byte addressable memory system, what is the size of memory supported? Question number 3, how does a static RAM cell function? Question number 4, how is a static RAM organized? Question number 5, how does a dynamic RAM function? Question number 6, what are RAS and CAS used for in a dynamic RAM? Thank you.